All right. So Deep Learning Studio is it has a free version, and then there is a pro version, uh, and there is enterprise version. For most of the learning activities, the free version is good enough. Uh, the pro version and the enterprise versions adds functionality related to accelerating of the training using GPUs. Uh, so anyone can go and download it. DeepCognition.ai. You can download the software. Once it's downloaded, it when you run it, uh, you could run it in a AWS. We have AWS image or Google Cloud. In this case, I'm running on a local laptop. Uh, it actually run as a web server. So if I go here to log in, and so let me use this login. Okay, so when you log in into the application, this is what you see. I don't have any projects created here right now, but they would be shown here as kind of a summary. Uh, and if we go to the projects tab here, this shows up uh, like sample projects that you can kind of use that as a starting point to see how things are done. And we have various different type of projects. There is a CNN based models, then there is a LSTM based model, RNN based models. In addition, we also have a mask card CNN type of segmentation model. So it's quite the software is quite flexible in the sense it can deal with different types of networks and different types of data. But for this demo, I will just create a simple. Uh, let's start with MNIST dataset. Right, it's a kind of very famous dataset for training. The way the dataset looks like, many of you guys probably might be aware of this dataset. These are a lot of handwritten digits, and the the idea is to kind of create a computer vision system that could read these numbers in a reliable fashion. And if you are aware of programming, you could see if this is not done through machine learning, if it is programmed, there is a lot of challenge there. As you can see, 2 is written by so many people in many different ways. So actually detecting pixel pattern is actually close to impossible. So, and this is where the machine learning advantage comes into picture, because machine learning allows uh, you to just have the system trained by just showing it many examples rather than actually doing the programming. So this data set is already available with the software when the software installs. So I'm gonna just create new project with custom neural net. So click OK. Going inside, so I select MNIST. You can see here it shows total number of records, which is 70,000. So it has 70,000 images of these handwritten digits, and you can basically browse it over here. But along with the image, we also have a label. So basically, that signifies this file belongs to this is the category for this image. Now, if you don't have enough memory, then you can do one. You don't need to load the whole data set in a RAM, and it could do one batch at a time. But I think I have enough memory, so I can do full data set in my RAM. That kind of accelerates the training process. In addition, you can, if you want, you can also apply some augmentation on these images. For example, they could be rotated, shifted randomly, and sheared. Also, flips are, you could also enable flip if needed. In addition, if these, let's say your data set has a different resolution images and they need to be all in this uniform, that can also be done over here. In this case, we already have all these images are 28 by 28 pixels. This is where you define your data set and also the division between the training and validation set. So here I've chosen, this is kind of default, which is 80,000, which is 80% for training and 20% for validation. So going to the model, there are 2 or 3 ways of doing it. We could use a pre-trained network and fine-tune that network onto this particular data set. So as you can see, we have pretty much all the latest type of CNN-based models, including ResNet 152, NASNet, which is, I believe, is a state of the art. Or you could actually layer by layer design your own network. I'm gonna just design my own network just to show you how a network is designed in these scenarios. So first thing is you're gonna bring in the input, and as you can see, as soon as I brought in, it shows me the tensor size. You can ignore this none because this is the batch size which is unknown at this point. But 28 by 28, that was the image, and 1 because it's a grayscale image, so you have only one plane. Now I could, once I got the input, then I'll probably move the output here. And output was selected in the data set here, and output type was selected as category. So as soon as the category is selected for output, the automatically anything that is needed to kind of convert that into a the way one hot encoding type of stuff, all that stuff is done automatically inside the deep learning studio. So our aim here is to convert these 28 by 28 numbers into 10 numbers, and each of those numbers will represent probability of that digits being that number. So just to tell you how the output will look like of this network, the output will have 10 numbers. So, and these numbers will be all these numbers actually represent probabilities, right? So you could see, let's say I have this 10 numbers like this. So 3, 4, 5, 6, 7, 8, 9, 10. So what happens is the output, what we are looking for is, let me count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this, the first number represent for this image, what is the probability that this image is a 0, is a letter 0, right? And so on, 2, 3. So what happens in reality is when you train the system, right, it might not give you a perfect answer. A perfect answer will be, for example, let's say this digit was 9. So this is a perfect answer you want to get, which is says that chance of this image being anything else except 9 is 0. And addition of all these probabilities are also 1, right? But in reality, when you actually run the system in the unknown images, you might not get this perfect. You might get, let's say, 0.85, and there are some probabilities distributed over this, but the total again is 1, because they should all add up to 1. And this is just to show you, typically when a deep learning system predict a class, it actually predicts all the not only predicting one class, it's actually predicting the probability of that sample to be for each of these classes. So we want that number to come here, right? So what I'm going to do is, I won't go into too many deep learning concepts here, because that's going to be completely different. But I'm going to make it through a very simple process. Uh, I'm going to make it a very simple layers. One of the simplest layer is the dense layer. So we'll just use dense layers and not use convolution layers, because probably it's way more simpler to explain from that. So let me go to the core layers. What I first want to do is, because dense layers don't work on 2D data, so I would just flatten it. As you can see, 28 by 28 into 1 turn into 784 numbers. And then I would apply dense layer, which is also sometimes called fully connected layer. And it's a pretty simple layer of neurons, artificial neurons. So I would say, now you need to tell what is the output of this layer, right? And how many outputs is going to do, and that is same as number of neurons it has. And I won't go into more details here. Also, again, typically, what you want to do by default, choose for internal layers. So I did 30. Let me do a couple of more. Maybe another 30. So this is definitely not the most optimal network, but this is probably much easier to understand what kind of processing is happening over here. And I can probably go into detail of how the fully connected layers works as well a little bit. So I brought it to 10 numbers right here, and what I will do is, if it's the final layer, instead of doing a ReLU, I'll do the softmax. And connect it to the output. So this creates a neural net, right? And you could also look at the neural net by clicking button. This is what you would have typed if you're using TensorFlow or /Keras. In addition to data ingestion code, is not shown over here. This is just showing the code for the TensorFlow part. I'll go to hyperparameter. Here I will define how many epochs I want to train. I'll put 100. How many batches? What is the batch size? And because I'm predicting a category, categorical cross entropy would be a good function to use. And optimizer is the piece of code that actually goes and adjusts the weights of the neural net. So the most famous being SGD, and that's the first one. It's a very basic stochastic gradient descent, but it can take long time for SGD to converge. So there are adaptive algorithms, ADA delta being one of them, which basically control the speed of learning automatically. Going to the training dashboard, I have one GPU showing over here, GTX 1060, and if I do start training, it'll show me various information about how much load GPU has, how much load CPU has, and how much system memory is free. And it will also, in a streaming fashion, plot the graphs for loss and accuracy. Any questions so far? So it's right now loading the network into the memory, and now it has started training. This is like a super simple network. Hopefully it works. If it doesn't work, I can show you how when these kind of things happen, how you look at your accuracy and loss, and figure out what are the next steps. And that's very common in deep learning. It's about it's about like looking at whether your model is overfitting, underfitting, and taking corresponding actions. Right now I can see that the model is not learning much, right? So this kind of thing is called underfitting, where your training itself is not improving. And when such thing happens, it means you do not have enough capacity in the model. What I mean by capacity is there is not enough neurons that are actually, the problem is too complex for amount of neurons we can put on work. Uh, so I would do stop here. I'll go back to the model. So easy thing I will do is just increase it to 100. Or maybe let me increase it to 300. Might be too big. Maybe not. You can increase the number of neurons by adding more layers also, or just making these layers big. So I'm going to also add another extra layer. Let me change it to 200. This might be too big. So that's okay. That's fine. Now let's see if we make any progress. While this is going on, I can also show you some few more features. We have this AI plugins, which is kind of a different way of building the neural net. But for example, mask casting and type of algorithms, they are not generally one algorithm. They are like a bunch of neural nets. So and you don't want to kind of modify these algorithms. You want to use it as it is, and we allow that by having these AI modules that could be in a very similar fashion. The way I'm doing the custom neural net to be trained, you can train them, but then there's no design aspect needed in training master training, because it's a basically pre-designed AI module. In addition, when you install Deep Learning Studio, you will also get a working installation of Jupyter Lab that can, be just like a regular Jupyter Lab. You can use it, and let's see. We also have we also have CVAT, which is I'm not sure if some of you are aware of it. Computer vision annotation tool. It's one of the most popular tools for annotating data sets, mostly images. So in general, this software is quite difficult to install, but we have productized this, and Learning Studio, you get this, get the whole installation automatically done. You don't need to follow any steps. And it's actually connected to Deep Learning Studio. So any data sets you label here, Deep Learning Studio will be able to see that. Now let's look at what's going on with our project. Okay, so this time it's going a little bit. Okay, so now you can see the loss is coming down and accuracy is going up. One more thing I can see, my GPU load is really not much, so which means that batch size is not efficient in this particular, whatever the batch size currently it is doing. If I just let it run, I mean, it will basically, it will reach, it's already 15% accuracy. We're gonna, I mean, probably not too high, but because it's a dense network. And they are in general inefficient for these type of image type of problems. So what I can do is stop this right now. But I want to show you one more thing. As you remember, we did run it before and we did run now. So the software will allow you to kind of compare. See, I made some changes, right? And then what is the effect? You could see there was an immediate effect that the loss is way lower, or not way lower, but it's lower, and more importantly, it was going down, right? And here accuracy is going up. So you could compare different changes that you do, and not only that, but you can also compare the network, like where the changes you made, right? So you could have side-by-side comparison. You can see here I've added this one extra layer, and these layers are changed. Oh, this is 50. Maybe by mistake I put it. So this shows you the changes in the that you made. This model can be deployed, which I'll show a little later. Let me go back again here. Let's design a convolution neural net this time instead of um, a fully connected network. So contour layer into this. I think it's probably beyond the scope right now to go into detail how convolution neural network works, but idea is that they have these what is called kernels, which are kind of a small uh, computational units that go over the image again and again and to detect something. For example, learn to detect a edge or a texture, things of those nature. But you would see the big difference uh, in terms of the speed of convolution network on the same image, because uh, convolutional neural networks are very efficient compared to the dense networks in terms of analyzing images. So you get not only higher accuracy but also get way more speed of training as well as inference. So what I'm doing here is I'm going to follow a very simple network uh, structure where it was found by I believe Oxford University. It's called VGG. It's an older network. It's basically what it did is basically put two convolution layers followed by a max pooling layer. So that pattern they figured out is very efficient uh, in getting the good results. So I'm just going to follow that simple pattern. Okay, right. So we did two convolution this. Now I'm going to repeat this pattern. Two convolution and one max pooling. And maybe reduce the filters. do another max pooling. Let's do once more. So at this point, I can use, I go to the code, flatten. Oh, yeah, I should put one task here. Yeah. Okay, and if you want to look at the source code, you can see what's going on here. This time we are using convolution layers instead of dense layers, right? And going to hyperparameter. And also last time I noticed that GPU was not utilized well. So what I can do is I can increase the batch size. That would typically lead to higher GPU load, and it makes it overall training more efficient. So let's try to see if we can make this work. And you can definitely see the uh, speed at which it's actually decreasing the loss is way higher than what we were getting with pure dense network. And GPU load went up a little bit, uh, not that much still. Kind of a simple network. And here it shows you like how many samples processing per second, and that'll give you an idea about how long the whole training process will take. So while this is going on, I'll show you a few more things. If you have any problem in like you know running the software or anything, we have a user that can be accessed within the software. I don't know why it's doing that. You can also access it from our website as well. Sources, community. So this you could ask questions here, and will help you, and also other users are helping as well. And you could also, for common problems, you can search here for solutions. Uh, Typically, so this would be a very helpful resource as you're working with Deep Learning Studio. So let's go here, go back to our model. So this model might take a while to kind of convert, sorry. So I think let me look at it. How we can maybe accelerate it somehow. Maybe reduce the number of filters. Or use the bad side. I'm just trying to reduce the size of the network, just to see if you can accelerate the training process. My laptop is not very fast, so if you wait for try again. Okay, so samples per second definitely gone up. GPU load has also gone up a little bit. Yeah, this is how you probably need to play around. This is the reason why we actually display this information. So you can make decisions, right? Like if you can see the GPU load, it's not fully loaded, or you can see, your GPU memory is still available. So you could make a decisions like what I just did. I just increase the batch size, and I also decrease the network size a little bit so that calculations are a bit less. And the first epoch is always a little bit slow because during first epoch, what happens is uh, during first epoch the loading of the data happens, and from second epoch onwards, uh, you know, it, data gets in the RAM, and then it's way more faster moving forward. It looks like this network has gone in the opposite direction. Let's see if it can. So this happens sometimes. You would design a network, and it would actually loss is going to go up even sometimes. And most of the time it's because of a very high learning rate. Um, it's basically a sign of underfitting. It also, like I said, I reduce this model, so I'm going to increase it back up. One more, okay, maybe not. This model was underfitting, so I'm gonna increase the model size now. Let's try now. So this is how typically, this is just an example. I'm showing you how I would try to, I'm solving this problem as if I'm solving for the first time. So this is a typical process of engineering a model. You go back and forth, and uh, this is why it's important to kind of have ability to compare your configurations, uh, and also track what things you have been changing over time. So not only that, but you can, one of the feature of deep learning studio allow you to kind of go back to the older model. Like if I do this, and I can revert this model back to my previous ones, and this model will go back to that version. So in a sense, it's the version control is built into this, into the software. So let's see now if we're going to give better results. Hmm. It looks like the learning rate is too high. We'll try a different optimizer. Let's see if that makes a difference. But any point of time, if you want to move, uh, go back to the coding from this, from what you have right now, you can actually download these models. One, three. Okay, so okay, I guess the problem is that to be able to download, you need to have at least one epoch finished. So those models didn't finish in one epoch. Okay, okay, it looked like that ADA delta was the issue. So ADA delta probably, I've seen it recently happening in a new version of ADA delta. It become too aggressive in terms of learning rates, and effectively model doesn't learn. As you can see that by just changing the hyperparameter from ADA to ADAM optimizer, you're getting way better results here. So model is 33%, and the samples per second is pretty good as well. So we will wait. So this is the model I would love to kind of train, because in very first epoch, it's making great progress. It's almost, at least on the training side. We'll see what happens on the validation. So while we are waiting, if you guys have any question, let me know. So this community is one resource. You also have another resource here, which are the basically how to do things with DeepCognition Studio. Now, how do you upload your own data set? How do you annotate the data set? And then there are many example videos which shows, uh, this MNIST example is shown with different types of neural nets. Here's how you can make an autoencoder. And there is an NLP example for sentiment analysis, or there's a movie review collection. And then you got, I think, also sentiment analysis somewhere. this one. Uh, so if you are working with standard data sets, many of them are covered over here. You should be able to just uh, look at this and then have a good starting point. So I believe that the epoch is done. It's actually calculating accuracy and validation set. Hopefully, okay, good. Took a little while, but now it's going to be way more faster. You can see the sample per second speed has gone to super high now, 2500. And that's because during the first epoch, it was decoding those JPEGs and loading into the RAM. Now in the second one, it has everything in the RAM at this point. Look at how fast this report was done. The orange line is a validation result, and the green line is training. So we have already got an accuracy of 94.8% on validation. And I don't know how much time it took. It took us 4 minutes to reach at this point, and it's going even higher. You see, like about 97 now. So, so this is the whole process. This is how deep learning theory works. And like you saw, right, the initial epoch might be slightly slower because that's where all the decodings of the image and processing of those images is happening. And but after that, it has got like 5 or 6 times faster. And in addition, you can also see GPU load has gone up, and it's pretty much loaded the GPU fully because it's now able to copy all these images uh, into the GPU really fast. So let me check some questions on the chat here. I'm just gonna go scroll up and start. Okay, how do you get to the page I'm showing? I think someone else has answered it. What happens is once you install Deep Learning Studio, what you want to do is type Deep Learning Studio Manager on the Start menu, and that will open this window. And this window has this command Deep Learning Control, and you can do these commands. But typically, only thing you need to do is Deep Learning Studio DLS control start, and you can also do status to see if it is running, because it has within Deep Learning Studio you have multiple components. Typically, all these components should be running for software to work, and you can see these servers are running here. It will also print a link that you can open in your browser um, for to access Deep Learning Studio interface. Let's see. And you don't want to run this command from a regular command prompt. This is a very specialized environment. So you want to make sure that you initiate this command prompt by typing Deepen Studio Manager. Any other questions? Yeah, installation takes a long time. The part of the reason is TensorFlow and other libraries that we use. They are very large. CWET is very large, but as it's one-time process, we think that I don't know if any of you guys have installed TensorFlow, PyTorch, or some of those. Generally, they take long time, and we also need to create many different environments for because many different components run um, in different Conda environments. What does epoch means? Epoch means once like when you look at the data here, the 56,000 images that were in the training. When a model goes through all 56,000 images, uh, that is called one epoch. And typically, model have to go over these 56,000 images again and again and again, and that is the number of epochs. For example, in this particular model that we're training, it will show how many epochs are done. I think my CPU is really loaded right now, and fan is running high, which is a good thing. So it's basically utilizing all computational resources of my laptop. Let's see if I can. Okay, here you can see it has done 16 epochs. By the way, you can stop at any point of time if you want to. Doesn't need to have. So let me do one thing. Let me stop this, right? And I'll show you the deploy piece. So I'll go to the deploy and I'll say my server. I want to deploy it on this instance. And I just press deploy, and that's it. So it will create a simple web application and also create a API server that will run on this PC and serve this model, right? So it showed, gave me a link that it has deployed over here. So it also provides me a REST API through which I can basically invoke this model and integrate this model with whatever the other application, whatever application somebody is trying to do. But it also create a small test web application that serves the model. So what we can do, we can go here to the data, and I can, let's just save this image, right? 5, 7, and this image is a 9. So what I can do is go to the deployment and drag this image over here and submit. So it should give us the answer of 9 because this model is having a accuracy of 98% plus. So I expect it to have really good accuracy. Oh, that's great. So it's telling it's a 9 with the probability of 1, which is very good. Other way you can kind of run inference is you can actually run it on the whole of the data set, whole of the validation subset, for example. That way you could see where the model is making mistakes, uh, by visually looking at the wrong answers. So that would be the last piece. Unless anyone of you have any specific questions. I think a validation had something like 50 56 and 70. 14,000 images. It takes a little while to run and display all the results here. Okay, so here you can see this is the actual ground truth, this is the prediction, and this is how much confident the model is for its answer. Interesting thing is if you go here, right? Here you can see this is 3, but model has predicted correctly with 0.57 being the highest probability of it being 3. And if I have to guess, the model is confused between 8 and 3 for this digit, because it has it can be, it's almost 8 if this would have connected a little bit, right? So, but here you can see, where model is not confident. Like on a difficult images, you would see model typically less confident, while on easy ones it's very confident. For example, here my guess is confused between 1 and 7. So, but it predicted still correctly with the 67% accuracy, 67% confident that it's 7. So with this, I think I will end this presentation. If you have any question, let me know. Gary, back to you.
Yep, so I'm not seeing any more questions. Thank you so much for presenting and showing us Deep Learning Studio. It's a great tool, especially for people sort of, who don't have the Python or coding background in AI, to be able to at least learn about how to build neural networks. So that's very cool, very interesting. And thank you for the time.
Thank you, everyone. Thank you, Gary. Bye.
Yep, bye. And if you guys have any questions about the setup, feel free to reach out to some of the mentors. Maybe they can help you out as well. I'm working on setting it up right now. So if you guys do have questions, once this does download, reach out to me as well and I can help you guys out. Well, thank you guys so much for showing up and participating. Hope you guys have a good time at the hackathon.